Okay, I'm told that that's my name in Chinese. I hope the characters don't mean anything bad. Um, this font that I'm using, that hacking background, this is influenced by the language that hackers use sometimes called Lott, where they substitute, in its simplest form, they substitute different characters for letters. I recently attended a class that was put on by an Intense School. That school is normally in Florida, and Microsoft flew out the instructor and arranged for a reduced price for Microsoft employees. And I learned quite a bit in that class about hacking, about the history of hacking, and about some models of how hackers work and the tools that they use. There's a textbook which I would recommend to you to read called Hackers Beware. In the class they also gave us CDs with a couple different versions of Linux on there. A lot of the hacking tools come out first or only for Linux. And the slides are available to you to look at from that class. There's like hundreds of slides. Then there was a supplement and the lab guide, which was the rest of the class material. And the class culminated in administering this certified ethical hacker exam, which I took and passed. So it was a really interesting class. Here's kind of an advertisement for the certified ethical hacker title that you can get. And it's from the EC console. The EC doesn't stand for Europe, it's not a European Union or anything like that. It's more like electronic commerce, e-commerce. That console puts it out. From the history of computer hacking, John van Neumann, who was the scientist who kind of invented the architecture of the conventional computer that we use to this day, wrote about the possibility of self-replicating computer programs back in 1949. So he kind of predicted that there would be things like viruses and worms that would be out there. In the 1960s at Bell Labs, the guys there played a game called Core Wars, where they would try to trample on each other's programs in the computer memory, and that was sort of the beginning of hostile software at that point. And then it was in at MIT in their AI lab where the term hacker originated. They borrowed that from another group at the school that was working on the hobby of putting together model trains. That people in that group called themselves hackers. In the 1970s, I'm going to move kind of quickly through this history here. The people who became the first computer hackers actually started out by playing with the telephone, trying to make free phone calls and so forth. And some of the famous people went on to become the founders of Apple computers. They were phone freaks, and then they started that company. How'd they do that? Make free phone calls? Well, I'll show you one way. There's a guy, John T. Draper, who has the nickname Captain Crunch. He discovered that in this free whistle that's given away in cereal, that produced a tone at precisely 2,600 hertz. And if you called like a toll-free number, an 800 number, and you blew 2,600 hertz, you could then dial any number after that, and that call would be free. So he found out through his own mischievous research to do that. So he's kind of famous in the history of phone and computer hacking. And you could buy these whistles on eBay for about $10. I don't know if they're the real ones or replicas. They don't work anymore because now the phone companies use out-of-band digital signaling. Okay, but back in the 60s and 70s, they used, the signals would go on the same cables as the voice conversations. In the early 80s, we had bulletin board systems spring up, and a lot of hackers kind of got started there, exchanging information. These bulletin board systems were kind of the precursor of today's internet. In 1983, there was a movie called War Games that brought the hacker character into the consciousness of people, of regular people. And then we start seeing computers broken into by teenagers, and arrests and all kinds of illegal activity happening. The first virus in the wild was called Elk Cloner, and it infected Apple II floppy disks, and it just displayed a harmless, silly verse. But you can see we've come a long way from there. Nowadays the programs are quite malicious in what they can do to your computer. The first MS-DOS virus was called Brain, and it was some Pakistani computer store's idea of how to make money. After reading that, people would try to contact the store to find out how to get rid of the virus. But even this virus is relatively harmless. Yeah, I just printed that message on the screen, and I guess they made, that computer store made some money off of that. People thinking that something worse had happened to their computers. 1990s. See macroviruses, and see Congress investigating and talking to hackers, finding out what they could do. Here's one famous case: the U.S. Department of Justice website was hacked. It was defaced. And there are actually websites, for example, this one down here, explains how to deface a website, based on the vulnerabilities that were in earlier versions of the various web servers. Lovebug was probably the virus that affected a lot of folks, maybe even in this room. You get a lot of email messages, hundreds or thousands, saying "I love you, I love you." Okay. So in this class. But I'm sure there's some.
But someone maybe on OTT might have it. Yeah. What does it do? I know it does send out a lot of emails to your friends and people.
I remember the details. Most of those early ones, the technique was they look at your address book, and then they spew themselves onto to other people's, and they try to masquerade as being from somewhere you knew. Right. But initially, the payload in them wasn't detrimental. It just spread the hog of resources. They started to get more obnoxious later on. Install other software systems. But I think the original one was just more of a resource. But it's been a while.
The gist of it is that it used to actually replicate itself by through IRC chat and through any auto mailing from the contact list for your own self, so other people would look at that and say, well, hey, that's my mom saying hi, and then basically it's spreading from there. So the main goal was that you couldn't use you couldn't use email and like trust the people that sending it to you as an excuse.
Yeah, I do remember the way you compress files. I was looking for the targeting season without DLLs on the system, and the place itself is a very simple call. To replace the virus itself is all the targeting season DLL files on the system.
Yeah, most viruses still spread that way. Once they get on your system, the techniques to hide them are numerous. They either try to hide under a common name, try to Trojan an existing file. I just looked at one the other day that tried to hide itself under run32 DLL. It was run32 underscore something .dll. And so you looked at it in the process list and you wouldn't really see it unless you knew what you're looking for. So that type of technique is pretty common.
I think lost work hours and the IT department's having to clean up. I think I don't know. There are various organizations out there that try to assign a cost to these different viruses, and they use different techniques. And I don't know if you can believe it or not, but at least for comparing relatively different viruses and the damage they do, it's probably worthwhile. I don't know about the absolute dollar figure. The hacking model taught in this class is based on the open source security testing methodology manual called OSTEM, and that's the and some of the steps in there. It has to do with, if you were hired to do a penetration testing of a company, what steps you would follow. First thing you do, you perform reconnaissance of the target and collect publicly available information, and I'll talk about some of those sources, and then scan for live hosts and devices on the corporation's network, find open ports, and identify the services on those ports, the application, the vendor, the version, build, and then look up in various databases the vulnerabilities that are known in those applications. Then you'd exploit one of those vulnerabilities to compromise the system, escalate privileges, and then do something to maintain access, like set up a backdoor so you can easily get into that machine later. Conceal, cover your tracks, and then use that computer as a way to jump to additional hosts to get additional information. As I mentioned earlier, Linux is usually the operating system of choice for most hacking tools. One interesting version of Linux is called Knoppix or Canopix, and that's totally RAM based. So you load it off a CD-ROM and it goes into your RAM. So you're not putting anything on your hard drive. So it makes it real easy to temporarily convert your system in just a few minutes to a Linux system. The first step would be the passive information gathering. This is where you can't really attract attention. You just look at publicly available sources to get information like like what technologies the company is using, what are the executives' names, information like that. A lot of the information can come from looking at the U.S. Security and Exchange Commission website, which has a database called EDGAR and has the various documents that public companies have to file on a regular basis. Look at news groups. Job listings are a good source of information because the hacker can look at what kind of skills the corporation is looking for in their recent hiring. If they're looking for Oracle, if they're looking for SQL Server, and from that, the hacker can infer what technologies the company is using. There's a site called Netcraft that identifies for websites the server that they're using and the operating system and how long that web server has been up. And there are other places. So that's where the hacker would start. The next step is technical information gathering, when there are various tools that someone can use to find out information about the domains that belong to a company, the IP addresses, and so forth. And there's some tools that work on Unix-based systems and Windows systems. There's certain websites you can go to because these companies have to register all that information for DNS servers and for various internet administrative purposes, and that's all publicly available information. there are other tools that can be used, like trace route. You can send a packet and then see where it goes. Every hop along the way to its destination, you could find out about how the network is structured. There's a tool called Firewalk, which lets you determine the rules for a company's firewall.
How do you get information about private?
I think what Telnet does is that you can put a time to live in each packet, and so it'll repeatedly send out these packets with first like a time to live of 1, time to live of 2, time to live of 3 hops, and they'll get a message back when the time to live expires, and that'll include the host on which the packet expired.
Also, I think Joe has something to add about that.
Yeah.
So the easiest way to do that actually is Telnet allows you to connect to any port and feed it information, right? So you port Telnet to port 25, and then if you SMTP is written originally in sort of a semi-English language, and if you type HELO, all capitals, it will, and the address you're from, then it will acknowledge you. And actually, HELP will give you the series of all the commands that you can feed it. One of them happens to be RCPT, which is recipient, and you can write a script to enumerate the accounts available on that box. So, like, for example, if I had a script and I could just run through a database of account names, potential names, it would return back whether that account was a valid account on that mail server. Now, from that, I could determine a series of accounts that I can now try to Telnet to 23 or SSH into or whatever not. So that would be one way that SMTP would provide a significant amount of information to the hacker. Additionally, oftentimes it will tell you what the version of SMTP it's running is and what box it's running on. So then by knowing that, I can go through and say, okay, well, I know that it's running, whatever, Qmail on Debian Linux or something, and I can go look up and see if that particular instance of that web server, or mail server or operating system has any holes that they haven't patched.
So I was working on isolated service is 1.2 and 3. After that, so I don't know. It's great that I hear this thing that people has that service that get information. I'm not sure what if they're doing patches against SMTP service to not return that information, because we have options to so let's say hello, and we say hello information service that may not be things out. Are we doing that now or not?
Could you try repeating the question?
Well, the question is
Well, the question had to do with whether we're doing anything to not give out information about SMTP servers. Yeah, I don't know if we can really answer that question. I do know there's a big debate going on about SMTP authentication right now on the internet. Who's going to own the standard? But we don't really cover SMTP too much. I mean, this is sort of a general discussion of security penetrations. And so I'm sure we do some. We've certainly had a few holes, but can't answer that question completely.
I think the question I was answering before, I think I misinterpreted your question, was about how traceroute works with the time to live packets. Okay. And then just by way of background, a TCP packet has these flags: urgent flag, acknowledgement, push, reset, so forth. And by sending the hacker sending isolated packets with one or more of these flags turned on, can tell whether a port is open or not, and often can tell the operating system or something about the service just from the way it responds to these packets. There's various ways that ports can be probed using tools. There's ping, which uses ICMP echo request and reply. You can see if particular host is alive, and if the certain ports are open. HPing 2 is a tool that you can use to craft packets that have certain flags turn on or off. So that's a very handy tool, just from a command line. Nmap is a more sophisticated tool that can send all kinds of combinations of packets and try to set up TCP connections or partial connections to determine the state of a port. There's a very general tool called Netcat that hacker can use for a lot of different purposes. And basically, it takes input takes standard input and sends it over the network to a particular host and port, and sends a response back to standard output. So it's a very simple program, but you can do a lot of interesting stuff with it. For example, you could set up a command shell on a remote system and start executing. Banner grabbing is when you run certain programs. It'll show a banner. It'll say this is version. This is Telnet version 23.25, and this way you can grab them and study those to figure out what's using that port. And then after learning the applications running on the different ports and the versions, there are various databases out there where you can look up vulnerabilities that have been found. And often from the description of the vulnerability, the hacker can infer how to exploit it. Microsoft tries to be careful and not give too many details when it's disclosing a vulnerability, so that it doesn't facilitate someone running an exploit. There's specific exploits that in the class that we studied. One was SQL injection. In there, you might have various fields on a web page that are used to build a SQL command, and by putting unexpected things like quotes, quote marks, and different keywords inside those fields, you can trick the server into performing a completely different SQL query or data manipulation statement than the author intended. And we also learned about IAS exploits. For example, you can go up the directory tree above where the website is. And some early versions of web servers let you do that. And then they patch that, and then by using an encoding percent and then a hexadecimal value instead of the backslash, then hackers were able to continue to exploit that because the parsers didn't recognize the %5c at one stage as being a backslash. And then when that was patched, some servers were still vulnerable to double decoding, where the percent sign itself was expressed as a hexadecimal encoded number. So we'll see Dan will show you some similar exploits used on the browser. I'm not going to go into all the details of these exploits. Now, once a hacker has compromised the system, there's programs out there that they can load on the compromised system that let them easily do the kind of things they'd want to do on the target system, like browse files, execute commands, all from a GUI interface. So it kind of so once they get to the place where they can get a program over to the victim's machine, they can do all these standard sort of things very easily with one program. Another topic we studied in the class was password cracking. We're just amazed at how easy it is for software to guess a password, especially if a password is short. It might just take a few seconds for it to determine the password. What you can do is by sniffing network packets, or if you get the SAM file from an NT or XP system that contains the encrypted passwords, and by using various programs, you can determine what the real passwords are. I'll just introduce some types of malware. These are different bad programs that do bad things. One is viruses. A virus can infect a file. So a virus kind of has to go into a host file, kind of alters the file and inserts itself. It's the definition of a virus. Although sometimes we use the word virus in a more general sense for all kinds of malware. Boot sector virus. These are less popular nowadays, but in the past, people booted off of floppy disks, and they weren't on networks, so there were a lot of boot sector viruses out there. Although you can have viruses that infect your hard drive, macro viruses, script viruses, just email, instant viruses. Worms are a program that just copies themselves as a whole and propagate from system to system. Trojan horse is a program that appears like a legitimate, useful program that someone tricks you into running, but it actually does something harmful to your system. We learned about wireless networks, how because there are various flaws in the design and implementation of them, that they're very easy to crack and break into. And they showed us in the class, showed us a movie on that, and we were able to crack these keys in less than 1 second after we collected enough packets from a wireless network. Social engineering is a category of hacking where you can bypass all these technical means, just trick someone into giving you their password or other information, or letting you use their machine, something like that, by misrepresenting who you are or what your purpose is. And let's move on to the next presentation.
Thank you very much, Mike. Just a reminder, actually, I know that some people will be leaving. Some people have meetings at 2, and some people have meetings at 3. We have actually a bunch of T-shirts, Internet Explorer T-shirts. I'll actually put them on the back. So if anyone's leaving in between presentations, feel free to pick one up.
So you're next? And then you will be talking after him?
Kind of alternate. Test. Testing. Oh, it's all right. Oh, geez. Thanks. Testing. Yep, there it goes. Cool. Can you hear me? Okay. My name is Dan Plaster. This is Joe Dibee, and we're from the Internet Explorer Security Test Team. And we're going to run through basically some of the common vulnerabilities in IE, sort of generally from least severe to worst, or most severe. Address bar spoofing and coding, but this is just a list. We'll dive into each one specifically. Probably the most obvious sort of thing is address bar spoofing, and it's sort of this, basically a level of trust. Let me step away from that microphone. Where's the pointer? Basically, I'm going to tell you, just so you know, if you don't already know, this is pretty obvious, but basically the address bar in IE represents what the... Let me switch it up. I can just Okay, here we go. Okay, basically what the address bar is this little piece of UI that tells the user what website they're at. You can type your name in, type in an address there, or you can click on a link in email or another web page, and it will navigate to some website. And that basically tells the user, or it's supposed to tell the user, where they're at, and it should agree with actually where they're at. The problem is people trust these things, and it's supposed to work. But one key point to make here is that web pages can contain subframes, iframes. Those don't actually have any address bar, and that's significant in some exploits. Past exploits we've had, basically that allow the hacker to misrepresent the address bar, have to do with some functionality which has recently been removed. This is a username password @ This is the ability to embed a basic authentication credential in an URL, and it was used very recently, very publicly. You can also use encoded double byte character sets in the URLs. You can use actually pluggable protocols to cause the address bar to fail. You can use special features within Internet Explorer, like full width embedded, which is essentially it's a type of display method. You can also use an old security feature that we didn't completely remove to cause the address bar to fail. And then you can also do other techniques of introducing script URLs into essentially what is Internet Explorer's history. Here's an example of basically what an URL looks like, a hacked URL, for both this 01 issue and the @ sign. And what happens here is you can see citibank.com on the left and www.msn.com, and unfortunately what will end up getting displayed in the browser is citibank.com in the address bar, but the content will be loaded from msn.com. And I got a quick demo to show you how slick this looks. So when I click on this link, oops, let me get this nice and big so you can all see it. Why did that kick off? You can see that the content loads from msn.com, but the address bar says something else. And this is a classic one. It was pretty public recently. Oops, yeah, that was the wrong button to hit. It was Shift F5, not F5. Okay, thanks. So this is just, I've got some other examples. I'm not going to show demos on all of them. This is another one where you just use purely using the @ sign to obfuscate the URL. People see this. You can see a lot of websites you go to. Get these big, huge, honking URLs with all sorts of stuff on them. People just look at what's on the left. In reality, this is what it looks like, which is why people think it's CNN, but it's not. And the deal is the hacker would own whatever is on the right-hand side, and then could fake the user into logging into their bank. They could spoof Citibank's website. That's a real popular one. Mike also alluded to earlier, basically encoding. What encoding gives you is, well, I should basically explain it to people who don't know. You can represent, for example, non-printable characters, and you can also represent non-ASCII characters via different encoding mechanisms. For instance, a slash, which is often used as a delimiter in URLs, can be encoded with the simple %XX, which is the hexadecimal value for that. For example, 2F. You can use a Unicode value for it. You can use these amp hash and amp hash hex forms. There's octal forms. The point here is there's a lot of different ways, and you can actually combine these multiple encoding mechanisms to defeat various parsers in different code. Here's an example of a past exploit where %2f in the previous slide represents the slash. But what would happen is this would navigate because of this. We treat this as this stuff being here being a username or a password. In fact, it's not. But what would happen here is we would navigate to the evil site, and the browser would, and then But the key is we would determine the domain of that website based on this, because we would take this as a slash character incorrectly in one place in the code. And this would allow the attacker to have domain access control, or sorry, DOM access to this yahoo.com page. So if they would navigate the user to, say, Citibank or whatever, and that user had a cookie, for instance, that was used to log in, the attacker could then steal that cookie and misrepresent or represent the user. Most secure websites usually don't fall for cookies as a mechanism for authentication, but a lot do. Another good example of parsing error is this thing. This was a suggested file name for download. Well, this is the null character. This is an encoded null character, and normally that's a string terminator. So what would happen is, in reality, this is an executable. When we would display this and we would check it, we would see this and go, okay, there's a null character. We had no control over this. The attacker does. So we'd say, oh, this is a readme.txt file. This is a safe file type. Let's just open it. So we did. Unfortunately, it was not a safe file type. And I'll just do a quick demo.
But when you try to open this file, you have no characters, right?
Well, no, because there's a number of checks. That's the problem. It's not one check for everything. When we would check to see if it was a safe file type, we'd process the null character. We'd terminate the string. We'd say, oh, it's readme.txt. Okay, it's safe. But we keep track of the URLs in different locations. That's part of the problem. The complexity of the program is there's not one sort of check for all security. You have an URL that you use to display. You have an URL that you do security checks on. And that's oftentimes the problem is there's multiple checks, and if you can figure ways around them.
I mean, when you pass your check and say, hey, this is not characters, and you don't have to worry about it.
Well, the thing is why does this still work? Because one bit of code would decode that into the null character. The next bit of code would not decode it. They would leave it in place. Yeah, this is just a quick, I'll turn this thing back on. Just a quick example. This is exactly the example you see. And the whole point there is we should prompt. It doesn't prompt, it just runs an exe. Simple, but dangerous, yeah. Should try to get Control F5 and not switch the screen.
Do say that.
Oh, Shift F5. Gotta hit the right key if you know what you're doing. And then this is a recent exploit. It's a little convoluted. I'm not going to demo it. I'm just going to talk about it. This is to do with multiple encodings, where we do different levels of decoding depending upon where we're at in the program. And that kind of gets back to what you asked before. Is, for instance, this is a %25. Well, that's actually percent. We convert that then to %25, which is yet another percent, and then we end up with a %00, which is the null character again. So this basically ends up terminating the string for some security checks, which is incorrect. The next section has to do with it's somewhat related to encoding. That's why I put them together, called URL parsing. It's just how we parse an URL. Just a brief explanation of what an URL is. This is a typical web URL, HTTP URL. That's the protocol. The left is the scheme or the protocol, and then there's a number of delimiters here that make up, the different ports of it. And this is important when you determine an URL, because when you take an URL, you want to do a couple things with it. You want to, for instance, say the website or the domain that it comes from, and that's important for security checks. And you want to be able to correctly determine where this chunk is in the string, because the attacker has control of the string. And then if you're going to do something, you call a file. You can have other directories. Key bits here is this is significant because this indicates file extension. This is typically a query parameter you pass to either a script, ASP, or PHP, or whatever. And then there's various things that are allowed. And there's actually quite a bit more allowed in this portion of the URL than there is in this, because this has to follow DNS restrictions. And that's significant in a number of ways. I'm not going to demo too much here. I'm just going to talk about it. This basically had to do with us incorrectly. This is kind of a mocked up of the original URL. But simply putting a dot on the end of the file. And we would incorrectly, in one case, this is an older vulnerability. I don't think we're this stupid anymore. But we would incorrectly determine the file type based upon that. It seems simple in retrospect, but a lot of these things are. So we have to be able to correctly break these up, and it's a lot more complicated in reality because you can get so many different types of file names, file types, and what can be encoded. Even more when you get into Unicode, full Unicode systems that support Asian language sets in particular, where you can get a lot more complicated problems. Here's another example, and this just has to do with when I talked about the query parameter and a special feature within IE, being able to basically inject script at the end of an URL and get it to run in the context of that website. This would be what you would call kind of a classic cross-site scripting attack. And here's a good case where basically the attacker is able to, you click on an URL, it looks fine. This script is able to run in the context of that website. And again, this would be the ability to steal users' content if it's sensitive content from a site. A secure site, in fact, would be easy to do. Or to be able to steal cookies. That's usually the biggest carrot with that sort of presentation. Well, yeah, in that particular case, it had to do with a special feature within IE. When you host certain documents, PDF documents, QuickTime documents, there's a special COM object that's a interface to the rendering engine that behaves differently because you want to display the content in the full width of the window. And there was this particular, in that specific instance, code error as to how we parsed the file extension, parsing the URL. I'm going to switch this over to Joe to talk about the next section.
Thanks, Dan. I'm going to talk real quick about Chromeless Windows. We are running a little bit behind, so I'm going to talk kind of fast. If you have any questions, please feel free to ask. Next slide. Chromeless Windows. What are Chromeless Windows? Chromeless Windows are windows that have or lack the typical features that we associate with a typical window. For example, the frame, the address bar, the title bar, the toolbar, the status bar. Typically they're pop-ups or custom UI portions. I'm sure you've seen them. And the interesting things about them is that they can be placed anywhere, they can be resized, and they're in the control of the parent window. Next slide. So how are they used? Well, yeah, as I said, they're used primarily as pop-ups and UI. Next slide, please. So how are they abused? You can imagine if you have a window that doesn't have a frame around it, and you can put it anywhere you want. You can put it in some pretty interesting places. And we've seen exploits where they've been put over dialog boxes, over the address box, over the entire screen, or they've been used to spoof the Control-Alt-Delete logon interface. Next slide, please. So I'm going to do a quick demonstration here. That's not my demonstration.
That doesn't work.
Try it again. F5.
Yeah, I ran this demo like 3 times beforehand.
You have to turn on back-to-back control.
No, actually, there's another problem. Well, sorry.
Okay, so if that demo had worked, what you would have seen is this particular security dialog box. And as it turns out, this is actually 2 Chromeless windows overlaid over the top of a security dialog box. And if this came up, and this is actually a screenshot, you can see it looks very authentic. And would you click on the yes?
Yeah, I think as far as the bad demo goes, this is what they actually, that bit there is what's overlays over that security.
So what ends up happening is that the user doesn't recognize that and clicks yes, and then runs an executable on their box. And at that point, the attacker pretty much owns them.
So it is a dialogue, a favorite one? This one?
No, what happened is we had two different dialogues. We had the security warning dialogue, which you get when you download a program off the internet, right? And then we've overlaid two more dialogues over it. So we've overlaid two chromeless windows. So there's a chromeless windows here that overlays the text of the security dialogue. And then there's another one here that says, there's what, yes, no, cancel, right? And so these two have been overlaid. And so now the only option really is yes. We have a lot of dialog boxes that look like that, right? Microsoft and Windows has crashed. Do you want to restart? Yes. Yeah, that one was pretty brutal. Let's see.
What are you going to do?
Here's another kind of example.
Okay, so this is what Dan's showing here is, and this one didn't work so well, but you can kind of see the the floating address bar there.
A little off a couple pixels, but you get the point.
But if this person had wanted to be a little more sophisticated, they probably could have got that to work. The next thing I'm going to talk about are TIFF disclosures. Next slide, please. What is a TIFF? It's the temporary internet folder, and that's pretty much like when you go to the internet and you download material, it goes into this special folder, and from there, we open it. And so I think of it as kind of like the mailbox on my house, in that things aren't really in my house yet, but they're in the mailbox, and I'm going to take them into the house. And the kinds of things that would be in the TIFF would be like, all the cookies that we download, the web page cache, any downloaded files, etc. That's the path to it on Win2K boxes. We're not going to talk about 9X boxes because they're inherently insecure. And one of the things that we do is we obfuscate this path so that programs don't know where they're at, right? Because the last thing you want to do is have a web page that can call itself and then subsequently do bad things from that. And so what we do is we use a file called the index.dat, which maps this obfuscation to the actual files that we have in the cache. Next slide, please. So the typical exploits that we've seen or come from this is they can get a basic disclosure of information. They can figure out, well, this is if the temporary internet file folder is no longer obfuscated from the file, then they can figure out where they're at. That file can figure out where it's at, and therefore can figure out the username and potentially the domain name. Like if you ever looked on your temporary internet files, it says your alias dot your realm or domain. But more seriously, it's used as a stepping stone for more severe exploits. Files get into the TIFF, and then they use that in combination with a cross-domain or zone elevation exploit to actually run those files from the TIFF. And we think of the TIFF as sort of the in to your machine from the internet. This is an example. Basically, this one I believe came from Liu Daiyu, who was working with MSR China for a while, but has since terminated his understanding with Microsoft. And he sends off a bogus type, and we can't handle it, so we return this error. And essentially, from that, the address bar displays where that error was, and the script is able to pick that up. So now this HTML file is aware of its location. And from that, all the other things that subsequently follow could potentially do so in combination with zone elevation or a cross-domain exploit. Next slide, please. Next thing I'm going to talk about is called MIME sniffing. Next slide, please. What is MIME sniffing? Well, it turns out the Internet Explorer, if it can't handle a file type or doesn't know how to map a file type, will look at the first initial portion of the file. I think it's about 256 bytes or something, and we'll try and figure out, like, what is this file? So if I send it joe.foo and it doesn't recognize foo as being a valid .3 extension, it'll go through the file and sniff the first section of the file and try and say, okay, well, this is, you know, an HTML page or something, and then render it as such. Next slide, please. And so the seriousness about that is that potentially if I had a firewall that blocked certain types like XEs or VBS or whatever, you could circumvent that and get hostile files through. And it looks like we have a demo.
Actually, we're just going to show.
Oh, just okay. So this time is running out. Okay, so this is a file that would be passed through, and MIME sniffing. If you look at the file itself, the MIME sniff, or pardon me, the file is not HTML, but when we MIME sniff this, we actually run script. The demo looks better, but.
Well, the whole point of this slide is it looks like half of it looks like junk because it is. It's binary data mixed with ASCII. But IE sniffs it and says, "Oh, well, looks like script. Let's run it."
So how do you fix that? Do you see any type instead of just the first one, which is okay?
Well, actually, Matt is going to talk about how we fix that shortly. The next thing I want to talk about is called user interaction. This is a wide class of vulnerabilities. Primarily, it's when a user initiates an action which has unintended results. For example, like the cornucopia virus, email virus, that went around where, you know, double-click on this beautiful picture of this naked, whatever, tennis star, whatever it was. And what they did in that particular instance was they took a file, you know, nude JPEG, and then they added a bunch of spaces to it and ran the end of the file off, which was .vbs. And so when the unsuspecting user opened that, it ran a VBS worm across their file system and their machine, and they were owned. Other examples, my favorite is called Click Hijack, and it was also developed by Lott. In this particular instance, what Lott did was he hijacked the click event. And so it turns out if you move a window on the down click, right, it thinks you're drag dropping. And so he was able to move the window out of the way and drag drop files onto the desktop. And yeah, I would like to demo this one.
Problem is, where did the file go? Sorry, this demo's a bit.
Go to the second one. Minor technical difficulties. Major technical difficulties.
Sorry. There's too much stuff left over from.
So what this demo is going to demonstrate is that the actual second instance of this is a function overwrite, but effectively does the same thing, does it programmatically. The function pointer, and click on that. So
See, the reason it's prompting me to add the link is because I already ran this repro and it already added the link. So what happens is I clicked on this link and I think I'm going to weather.com, and it adds it to my favorites. And so it's unintended consequences.
I just deleted this from my favorites, so it'll do it again. Oops, there it is. The original exploit, which is a little bit harder to demo, was actually able to drop files on your desktop. And the point there is you can drop them into your startup group, you can drop them into a variety of locations, and next reboot, next login, they run.
So the file is, where's the file? The file you drop, where would the store the files?
Where is the file coming from?
The attacker's website.
Okay, so whatever website that displays that string and say click here. Okay.
Thanks. And I saw in the script you dropped actually the root of the.
I saw in the script you drop the file actually to the root of the C directory, but not everyone have the access to it. Only.
Yeah, I mean, you can. Yeah, I mean, you can control where you drop it to. I mean, this vulnerability of itself is not as bad as others because there's some mitigations. You can typically drop it to the desktop because that's where the browser is running from. It tends to be where you started the application from. So yeah, if the user doesn't have access to the C drive because you've locked the system down, you can mitigate this. But think of the average home user. They don't have anything locked down. They probably run in Windows 98. Even if they have XP, they have the thing with low security settings. So you have to look at your exposure.
So user interactions are the primary vector for email viruses, as it's noted here. And it's kind of an interesting realm where you've mixed some programmatic things, programmatic glitches that we have with some social engineering. And it's sort of in a lot of ways, it's a great area to fix, which makes it that much more devastating. Next slide. We've already done that one. And the next thing I'm going to talk about is cross-domain scripting. Just crank through this real quick. So what is cross-domain scripting? Cross-domain scripting is when scripts in one domain can access information from the other. For example, evil.com can access the contents of Citibank. The common examples of where we've run into this issue is like in frames and special URLs and in certain instances of incorrect URL parsing. Pretty much any time that a domain URL loses its context, you have a potential for cross-domain exploit. That's not to be confused, mind you, with cross-site scripting, which is primarily a server-side issue. Next slide, please. So how are they used? They're used to run cookies, steal data, or pardon me, run cookies, steal cookies, steal data. They can also run script in the context of a user. Typically, they're combined with TIFF disclosures, which we talked about previously, to run a code from the attacker's choice. So like they run it into your TIFF directory, and then through zone elevation and across domain exploit, they would get access to that. So that's how they get into the box. Next slide, please. So I was going to do a quick demo, but looks like we're running a bit short. So maybe. I'm done, but Dan's got a few, I think.
Skip it? Okay.
I'll talk over it really quick. So basically what it is this has also come from Lott in China, and what he figured out was that the JavaScript colon protocol loses its context, and so if you put it into the history, it loses where it came from, and so when you recall it, it then runs in the local machine zone instead of on the internet zone, and so then he's able to do all sorts of nasty things from that.
So I'm sure you would have touched that topics is the zone concept in Explorer. Is that the same concept as like domain, or what's the zone concept?
We have a whole presentation on zones.
That's the next topic. Next slide.
I'm going to talk about buffer overruns. As far as exploiting code, buffer overruns and zone exploits are probably, as far as IE is concerned, just about the same, because what they get you is arbitrary code execution. Buffer overruns are well known, or at least they should be well known. I'm going to go over what they are. Basically, you allocate data on the stack for an application, or you can also allocate it on the heap. Dynamic data is allocated on the heap, statically defined variables are defined on the stack, and if they're not correctly bounded, the problem is the attacker, if they can control what that buffer is that's being copied, they can run arbitrary code. These are, so when I say a little bit more difficult to exploit, it's pretty trivial for most people, it seems, on the internet. At least one guy does it, then everybody has it. Whereas a lot of our script exploits are simpler for people to exploit. But nevertheless, the consequences are arbitrary code execution, and they're pretty bad. If you remember Slammer and a number of other buffer overruns, you'll had suffered through that, you'd know. Basically, I'm going to talk about stack-based buffer overflow first. This is basically the structure of the stack. This is an application stack. You have a return address, you have a base pointer, you have your local variables, and then the rest of the function that's on the stack. And then what happens is, as you can see, this is a crummy piece of code. It takes in a source buffer, which is what the attacker owns. It has a statically defined destination buffer, and it just copies them blindly. We don't know actually how big this is. We've done no validation on what size that is. So what happens is we start to copy. You can see where SC destination is. We start filling this up, and we actually overwrite the whole thing. This is just a classic stack-based buffer overrun. It's probably the simplest, most straightforward, and the most abused vulnerability. When you own the return address, you can then jump to your own code. It's a little more complicated, but it's not difficult for people to exploit it. I'm not going to actually demo this. I'm not going to demo any overruns because we actually have a much better presentation after mine. David Litchfield's going to show not only the heap overrun, but how to exploit it, to run arbitrary code. This is an example we had of one in IE where you passed in a whole bunch of slashes, and typically when you want to test to see if you've got a buffer overrun, you want to write a character that you know and recognize. For example, capital A is 41 in hex, and so when you look at a debug spew or a crash, you can quickly see if you have influenced any important buffers registered or if the stack is smashed itself. Here's the code. I'm not going to get into it too much. These are the red bits are the fixes. But basically, this was a special feature we had where we encoded. If we had a slash, we would keep it as a special encoded format, but we didn't correctly allocate enough space for that. And if you look at a debug spew, you can see here when it crashes, our stack is we can't get any symbols, actually, because we have debug symbols inside the company. Nothing will match because you have messed up the stack. This doesn't look like a classic. Usually, you'll see your return address and your base pointer overwritten, but the key bit here is your instruction pointer is overwritten with the attacker's choice, and you can also see the base pointer is overridden. This is a heap overrun. Again, I'm not going to demo it because David Litchfield's got a much better presentation. But basically, this is data that's allocated on the heap. And the heap is a section of memory where you can dynamically allocate memory for variables at runtime and a variety of other things. The key here is that when you debug these, you'll see, and I forgot to highlight it, that the general purpose registers EAX and ECX have been overwritten with the attacker's code. And so then these are a little bit more difficult to exploit. There hasn't been a lot of published stuff, but they're definitely, and David Litchfield actually has a very good example of this. So it used to be believed that heap overruns were not exploitable, but there was a paper a number of years ago in Linux against libc, I believe, of exploiting it, and certainly you can do it in Windows. Anybody who assumes otherwise is wrong. Now getting back more to sort of a classic IE problem, zone elevation, you asked about that. What goes on in IE is IE has a security mechanism called zones, and these have to do with how it breaks up security boundaries and levels of trust. These zones are defined here from local machine zone, trusted sites, local internet, and restricted sites, and this is basically from the least secure, most permissive local machine zone to restricted sites where you can't do anything. The local machine zone is essentially resources on the box. That is files on the system. If you wanted to run script from your local machine, it's allowed to do a lot of things. There's a lot of ActiveX controls installed by default that can do a whole lot of bad things. And so it is the target of choice for the attackers. I'm not going to get into too much of the other one. Local intranet is basically represents a corporate network, which has a higher level of implied trust. The internet zone is generally fairly well untrusted because you don't have control of what comes from there. And then restricted sites is just a site where you can arbitrarily put in sites you really don't trust into. Like I said before, the whole point is the attacker controls the internet zone, and what they're going to try to do is elevate into the LMZ and then run code. The classic example is how to instantiate an ActiveX control. If you can run an ActiveX control with this script here, and what this will do is this code base means go get this stuff and run it. Well, in reality, from the local machine zone, this will run without prompt. So if the attacker can get their script into the local machine zone, they're able to run this without prompt. And why this is significant in relation to buffer overruns is because you got to be a little more technically oriented to exploit a buffer overrun. This, people just cut and paste and exploit. Script kiddies love this sort of junk. Another example are some controls that do bad things. For instance, this is an ActiveX control called ADO-DB.stream. It's for pulling down web server content. It was originally designed for ASP pages, but you can use it in IE, and people have. And what this does is once the script's running in the local machine zone, it can use this XML HTTP GET to get an executable. We don't prompt. Then it can take this, grab the stream, and then write it to disk. And in this case, we're just writing it to the local file to prove that we can do it. But you can overwrite an existing file and then invoke it. Want to do a demo? I'm going to show you my C drive to prove that I don't already have this executable on the system. As you can see, there's no evil exe.exe there. And this script is already in the local machine zone. We've already elevated to there. Something goes on, and then if we come back to you'll see a significant thing here, and that is what I just messed up. Evil.exe now exists in the file list. It is, you didn't see anything happen. How this also is exploited is they could try to overwrite an existing system file or something that they can invoke. For instance, one case they invoked Notepad, they overwrote Notepad and then called view source protocol, which invokes Notepad automatically. Boom, the executable runs. I'm not going to demo this one, but here's another example of using nested protocols with the code base to basically, this also defeats our ActiveX control block because we don't actually, this is an unsigned exe. It has no digital signature on it, and then we'll run it without checking. It circumvents some of our checking. And this looks kind of, I should explain this a bit more too. The MHTML protocol is an RFC standard for building encoded content into one file. For example, you can email uses MIME encoding. Stands for multi-purpose internet mail extensions, I think. You can also save websites as bundled up files. They have chunks, they have delimiters and stuff. And one of the mechanisms is that you can use this delimiter bang to call content within this file. But as you see, as it's been labeled, this file doesn't actually exist. And what we fail to correctly do is we look at this and we say, oh, C drive, that's a local machine zone. Okay, cool. Then we see this bang. We say, okay, this is the content within that file. When we go try to find this file, it doesn't exist. We go, okay, well, let's go get this instead. But we are now in this zone, which is unfortunate. Then I want to talk about, this is sort of a follow-up to all the others, basically variations. And this is important really for security testing is you either find an exploit or somebody gives it to you because they post it publicly or they privately contact you saying, hey, we found a security vulnerability. And oftentimes there's more than one way to exploit it, more than one way to skin a cat. And some of the common methods that are used, you have to understand Trident, which is the rendering engine in IE, is a complicated beast with a lot of asynchronous action going on, and so you can oftentimes, if you do it one way and we fix it, you can also circumvent it by going in through a completely different path. And so what we're just going to talk about here is that there are other ActiveX controls that are provided by the browser itself. For instance, the WebOC is a scriptable COM object version of the host for our rendering engine. There's a scriptlet control that you can use to containerize script, and it can do sorts of bad things. There's other common interfaces provided by Trident that are often exploited. Various encoding mechanisms, we talked about that on encoding. Canonicalization bugs are critical, where you have a non-standard representation. That's not merely Unicode, but you can actually, or not merely ASCII encoded, but you can use what are called overly wide Unicode strings, alternate code paths, or what I was getting into is other tags, ways to get information into, if you exploit it through an image source tag, can you do it through anything else that takes a source attribute? Redirects are an interesting thing. In particular, web servers typically do this. You travel to some website and they say, oh, the contents moved to here, go there. And we, unfortunately, due to the way we handle things, can oftentimes actually go down a different code path on a redirect because we think it's somewhat safer than a pure navigation. Also, pop-ups. We talked about Chromeless windows and pop-ups. So sometimes pop-ups are a special thing in IE in particular because they're sort of a stupid window. We don't check for any return calls from the windows. We don't check to see whether the content is loaded or not. We just throw the content at the window and we pop it on the UI. And so it's a fairly simple thing, but it also doesn't have a lot of checks in it. These are talking about, here was a denial of service attack we had using an image source tag pointing to a mail call, which is a completely bogus thing to do, but it actually would lock up the email client. Well, you can actually do the same thing with background sound source. And unfortunately, if you look through MSDN with HTML tags with source attributes, you will find that there are a lot. And so unfortunately, you have to look at all of these. Another example that we got beat around the head with was a method. This was actually a way to run arbitrary code. It was a zone elevation exploit. And you can actually get around it via different ways. We internally found that you can invoke originally it invoked an HTML executable, bypassed a security check. Internally it was found that you could do the same thing even with our fix in place with a database, an MDB, which is an access database file format, which actually can run code. Then publicly somebody came out with an XML data island variation and the pop-up variation, which also bypassed our fix, because basically there was an insecure code path that everything was going down, and you can patch each one of them, or you can try to find the root cause and block it there. That's oftentimes hard to do under a lot of pressure. So this is the pop-up variation. Then lastly, we're going to talk on this part of the presentation, then we'll go into the XPSP2 stuff. We're going to talk about some tools. I think Mike covered that some. We'll just kind of rip through basically the arsenal that we have. You mentioned Netcat. There's a lot of little command line tools. Some of these are ported from Unix. wfet, wget. I'll actually go into each one of these specifically. Netcat is handy. It's really a Unix tool. It allows you to put arbitrary content out to on a port, listen on a port. You can also pull stuff off of arbitrary ports. It's handy for pulling down. If you want to capture somebody has a hacked website and they're returning custom headers and you want to just grab everything in one big chunk, it's really slick for doing that sort of stuff. Mostly for IE, that's what we use it for. For network penetration, they use it for a lot of other stuff. All right, that was your slide. wget, wfetch is another little tool that we use. wfetch is a Microsoft tool. wget's a GNU tool. And this just allows you to pull content down off websites if you don't want to browse there. This is sometimes handy because they're trying to exploit the very browser that you're using. Okay, Netmon, if you're familiar with packet sniffers, Netmon is a packet sniffer. Ethereal is another one that's Unix form supported to Windows that you can also use. It's available on the internet. What this does is you can sniff all of the TCP/IP traffic between hosts, particularly if you're trying to debug an issue or figure out what's going on, or you actually want to grab the raw headers if the attacker or the exploit is doing something specific. So internal tools that we have that are called ActiveX Interrogator and ActiveX Hack, and these are both COM objects that you can install that will allow you to enumerate methods and properties on an ActiveX control. ActiveHack is useful for that, particularly if you're trying to build an exploit. ActiveX Interrogator is sort of a more general purpose tool that has kind of a pre-built list of scripts that go with it that you can feed it content to, and it can go enumerate methods and give them big, huge buffers to see if they choke and crash. Web text converter, it says external. I don't know where it actually came from, but this is just a tool used to quickly generate encoded forms. You want to get all encoded forms for a particular character for an exploit. It just enables you to quickly do that. There's another tool that's developed internally. I'm sure there's stuff on the internet called overly wide Unicode, and that has to do with non-canonical representations of Unicode characters. So it's really handy to see if a program that's supposed to be Unicode correctly handles these and converts them down into them or discards them like it's supposed to. W3 Spoof is an internal Microsoft tool. This is handy. This is basically a custom web server. It's a scriptable web server that listens on an arbitrary port, and you have direct access to the wire. Sometimes it's difficult to do exploits with ASP or even PHP on an Apache box because sometimes the web servers themselves will add headers in that you don't want. This gives you direct access. You can literally write out a text file with HTTP headers and everything, the script, and it'll just squirt it across the wire as is. And lastly, common tool we use is Perl, scripting language. The active state makes a Win32 port of it. It's handy because a lot of times if you need to write a custom server for something that you can't quite do with W3 Spoof, or I wrote a Gopher server, just a hacked Gopher server in this once for a buffer overrun. So it's really handy to do that sort of thing. This goes on to the next presentation. Are there any questions on that part of it? I'm going to pass this over to Matt Lott.
Hello? Okay. So I'm going to talk about some of the new security mitigations and tools that we're adding to IE for XBSP2 that will make browsing safer. So you've heard about the local machine zone in a few places in the common vulnerabilities, and so one of the things that we're doing in XBSP2 is locking this down so that locking it down for the IE Explorer process. So by default, script and ActiveX won't be able to run in the local machine. I actually have a demo of this. So this is an XBSP2 machine, and this is just a local file. And so it's trying to run script and load an ActiveX control, and this is no longer allowed. What we do see is the new information bar which says, well, we blocked something, and if you really want it to load, you can do that by saying allow this page to access my computer. By selecting this, it gives you another little warning. But what it does is it reverts to the old XBSP1 settings, and so you see there's an ActiveX control now running, and script is now running. So this is sort of a last defense, mitigation, so that if someone does get a page onto the local machine and does get it running, we'll try to restrict the security settings so it can't actually do anything harmful. So I know there was a question about the MIME sniffing earlier. For XBSP2, we're changing how we handle files that come down. Before, we used to rely a lot on MIME sniffing and what we thought the file should be. We'd look at it and say, well, this looks like an HTML page, or this looks like some other file type, and we'll try to run it as that. Now we add a lot more weight to what the file type is, what the MIME type from the server is, what the file associations are in the registry. And so based on that, and to a very small degree, what we actually sniff the file and what we think it looks like, based on that we run it. The result of this is that you see more actual just file download prompts, where before when we used to see a file and sniff it and say, well, we think it's probably this, so we'll just load it in IE or we'll execute it. We no longer make those assumptions for the most part. And I can show you an example of this. So the new behavior, this is a text file that has a script tag in it. And you see the script tag there. And so since it comes down as a text file, we say, all right, we'll load it as a text file. Text file is a safe file type. The old behavior was we'd see that script tag and we say, well, we'll load that as a page, right? Script runs. So we also added zone elevation security mitigation, which tries to stop navigation from a lower privilege zone to a higher privilege zone. And again, this is just for the IE process. But basically, based on which zone you're trying to navigate to, the user is going to see different things. So we still always allow you to navigate to the internet zone and the restricted sites, because those are relatively low privilege zones. We're going to just outright block the My Computer zone, and we'll provide a prompt for navigating to the trusted sites and internet sites. And so basically this tries to stave off zone elevation and then doing bad things once you're in a higher privilege zone. And I'll show you an example of this. So this is hard to see. All right, so I can't see the zone. Just a minute, let me try to grab this. All right. So this page is in the internet zone, and it's trying to navigate to an intranet site. And so users prompted and says, well, do you want to navigate to this higher privilege site? This could be unsafe. And so if they hit cancel, then navigation is stopped. And you're still allowed to continue on and navigate if you'd like.
So how would you, so you expect the user to judge whether the zone, whether the page you're navigating to is safe or not?
We're trying to explain with the dialogue that, this might be unsafe. So we block if you're trying to navigate to the My Computer zone, which is, sort of a scenario which we really don't expect and can be very dangerous, right? Navigating to the internet site is less dangerous, and we feel safe in giving the user a choice. Well, this could be dangerous. Do you really want to, do you really know what you're doing?
But the trusted site is also the same as
trusted sites and the intranet site are treated the same as zone elevation is applied. Do you mean the security settings that are applied to the? I see. Yes, that is probably true that the privileges are higher for trusted sites.
So you rely on the user to say HTML column / SW is a trusted site that you can navigate.
Yes, we are just given the user navigation. And the reason we still prompt for trusted sites is because it's going to be harder for an attacker to guess a specific trusted site. So it's still not too unsafe.
Are you going to provide function like just read the HTML tags for that page and really allow that page to run in the system? So at least you can read something from that site.
So now, like a preview of
Right, a
your
preview for
actual
the tags on that site rather than run anything swift on that site. That's kind of like, I want to find out information about that site.
Are you talking about the local machine zone?
the site that you're blocking to navigate.
Right.
to.
Oh, I see. No. Well, right. So at the moment, no, we don't. We just provide the zone that you're trying to navigate to.
So one thing I'm thinking is this site, if you've never been there, and just said HTTP colon www.something.com, then you've never been there, how would you know that the user will know this is trusted? So if you say, hey, I've never been to that website, and you try to elevate my zone to a higher privilege zone, I shouldn't do that.
So I guess it's hard to determine the case, from our standpoint, whether the user really wants to go to this site or not. So that's sort of why we're providing the prompt. We hope that they have enough information to say, well, this is the site that I actually wanted to go to, and I can see, where it's going.
Before you really confirm.
Right. Yep.
Did we do a study on the ratio of pop-ups as to 3S?
The ratio.
Right, on the regular use, how often does the user get prompted with pop-ups? Warning. What's the ratio?
I don't know of any specific studies. I know that in XPSV2 we've added features to reduce the number of pop-ups and provide information like you saw the alert bar that popped up for the local file. So we also, for modal dialogues that come up for, say, ActiveX controls and that sort of thing, instead of popping up all those dialogues, we now show the alert bar instead, providing sort of a modeless UI for the user so that they can kind of continue on doing what they're doing. And if they really wanted to install those ActiveXs or deal with those dialogues, then they can select from the alert bar that pops down to get back to the old dialogues that were shown.
The question was about usability study regarding pop-ups. I believe that has been done. I don't know the data of that.
Okay, it sounds like, it sounds like we're seeing more pops up to class user to make actions based on that.
Right, I'm trying to figure out first nuisance to the user in terms of usability, and also how much of them are just UI. Well, they took a bar, but they did try to reduce the number of prompts, partly because one of the issues was people would get prompted and they just go, okay, just go away. Boom, too late, you're happy. And so they tried to, for one, make the default cancel. They try to reduce them, but at the same time put more information in. It's a tough thing to do because, you can say, well, you can prompt everywhere and you just hate it, nobody wants to use it. Well, gosh, it's not more secure. But if you also window down to one decision, and to make the wrong one, game over. So it's you have to realize also the level of experience. When you think of the Microsoft people who are hackers or people who are very technically savvy versus my mother. That's a classic example. Everybody. I think my mother, she barely knows how to turn the switch on. And so she sees a few things and she doesn't know. So yeah, it's a tough middle ground. But we have tried to reduce the number and give more information so people won't be so driven to just can't, we're done. Which is good. We need to redesign it.
But that's the identity.
There was after one.
So we also turned off binary behaviors in the restricted zone. And so with this, basically the idea here is that, I'll back up. Binary behaviors are a default functionality that's in IE that basically allows you to do sort of an animation or different more elaborate media things or paint up text in sort of a cool formatting way. The problem with this is that this is more or less an ActiveX control that is already with IE, and if you can exploit it, you get binary code running. So we turn this off in the restricted zone because a lot of HTML email clients do or should be viewing their email in that, and so we wanted to avoid spreading exploits via that method. And I will show you a demo here, but basically, they're just turned off in the restricted zone. So we've already seen a little bit of this. For XPSP2, we're restricting what you can do with Windows via script. So, for example, if you show a pop-up via script, you're not allowed to move it completely away from the window, or you're not allowed to obscure the status bar or the menu bar and try to fool the user into thinking they're somewhere they're not or making a bad decision. Along those same lines, you're not allowed to create a new window with the full screen capability, which doesn't have a status bar, or you're not allowed to create a new window without basically the Chrome around it. We saw the example earlier where they're obscuring a dialogue, and so we're trying to stop that sort of thing. So we also added a pop-up blocker to XPSP2, and I can show you a little example of this. So basically, again, we see the alert bar, which is sort of becoming a common method for telling the user something was blocked in XPSP2. And you still have the ability to show the pop-up, or turn off the pop-up, or allow pop-ups for just this site.
Is there a reason why it's blocked?
Why the pop-up is blocked?
Yeah.
I don't think we make any determination on the pop-up except that it's non-user initiated. So we're trying to block, a bunch of ads from coming up and that sort of thing, right? It's still sort of a security method, but it's kind of an annoyance as well, right? So, like if you still click on a link, it's user initiated, that will pop. Yeah.
I don't think it's good to get to it. I haven't seen the fix to the click hijack.
Oh, the click hijack? So we actually fixed that in a patch where I believe we don't allow the drag and drop when there's a mouse down event. Is that? Really good.
The question was how we fix the click hijack, and we fix that by blocking script instantiated move by, resize, and a third call when the mouse was down. When the mouse was depressed, programmatically you couldn't move the window. So that's how we blocked that.
So this is just showing how we give a little more information in dialogues when ActiveX comes up. And above you see the alert bar that will initially pop, and then if you select on the alert bar, you get to see the old dialog here asking you what you want to do with this control. So we also added a add-on manager, which lets us see which controls have been used by IE and which controls are actually running at the moment. And this is basically giving the user more control on what is able to run in IE. I can show you that here. So this is currently what's running in my IE instance here. This is what's been used, and you can disable and then enable controls. So most of these security settings are only on for IE by default, but other processes can opt into them to take advantage of these mitigations as well. And we provide an API for that, and a lot of these settings are also can be administered by group policy. So are there any XPSP2 questions?
Yeah, it's one of general questions. How do you decide when to put a fixed patch versus a fixed CSP?
Well, a lot of it, Mark Silvey, our security PM sitting back there, could probably answer the question. The question is, how do we decide when to, or how to fix, whether it goes into a patch or a service pack? Primarily, it's severity. There's a ranking mechanism that we use, a severity mechanism, to determine whether or not a particular bug is really bad. I mean, obviously, remote execution of arbitrary code without user interaction is probably the ugliest, whether that's an overrun or a zone elevation exploit. And then it goes down from there. Personal information disclosure is a big issue. But there's a whole triage bar, basically, they use to determine whether a bug is either a won't fix if it's not a vulnerability, or whether it's a service pack level type fix, or whether it's a patch that needs to be out in X amount of time, or a patch that needs to be out yesterday.
So, Dan's right on. Basically, the Microsoft Security Response Center has a triage bar that goes across all of Microsoft to evaluate the different severity, priority, and likelihood of security issues and how to ship the fixes for those issues, whether they go to service pack or whether they go to security patch. It's based on those three things, so severity being how much does it hurt the user, priority being how publicly known this is being exploited out in the wild, is it published up to a website, and likelihood is also how likely is it to be exploited. So that's
So another question I had is when you issue patches or SPs, would there be customers out there that has websites that some of the features, they consider features get broken by some offenses? I don't know if you guys want to take that.
Okay, could you repeat the question?
Yeah, well, the question is, so let's say this pop-up dialogues, we block that, and some of the commercial sites rely on that to block commercial sites. That's just one example. So is there any cases where some of the fix you put in patches or SPs that breaks the commercial
Yeah,
sites?
a good example is our most recent patch where we the question was, do we have problems with our patches? Their security fixes break customers. Yes. We have a good example is most recent patch where we disabled username : password functionality in URLs. And we communicated this ahead of time, but it's the difficulty with patches is you have one chance to get it right. You don't have a beta. You don't have a big, long time to float the project and have people do app compat testing for you. So you try to do it as big as possible, but meanwhile people are getting exploited. And so it's a constant balance, and you look bad if you don't fix the security issue, and you look bad if you break a customer. But a lot of times we try to take the approach of we need to secure people first. And so, yeah, we have broken customers with our security fixes.
So I can imagine you guys have a big app pages.
Yeah, it's getting bigger every day. Yeah, we're getting bigger, but the problem is IE is a component that's installed in everything. And so it's everywhere. And the trick there too, as you don't realize, is we support MT4. We support all the way up to Windows 2003. It was Windows 98, Windows Millennium, Windows 2000, Service Pack 2, 3, and 4, XP Gold, XPSP1, Server 2003, and XPSP2 here in a bit. So there's a lot combined with IE 501, IE 55, IE 6, IE 6 SP1. And how many languages do we localize in? 25 languages. So the matrix expands rapidly, and so people go, Microsoft stinks. They can't release a patch in X amount of time, and they're right to some extent, but they're also it's difficult to do, and they don't really realize just how big of a task it can be. And we have our problems, and Microsoft in general has their problems, and there's certainly a lot of work that's being done to try to speed these up, but at the same time ensure quality. It's not an easy task to do.
So I guess given the limited resources and bandwidth, you guys don't actively monitor the hackers community.
Oh, yes, we do. Oh, yes, we do. Yeah, the question was, do we have enough time to moderate the hacker communities? Yes, we do. Plus, MSRC has people.
We don't necessarily have the time.
Yeah, we don't necessarily have the time, but we do it anyway because we pick up exploits there all the time. It's at least my perception is there's a lot of the guys who report the IE-related vulnerabilities like to go public without bothering to inform Microsoft, but that's just my general opinion. It just varies. I mean, we have people who privately work with us, but there's also and we also get stuff where customers say, hey, we've been hacked with X, Y, or Z. Here's the stuff. And we look at it and we go, I've never seen this before. This is not good. Most of the time we see those, we go, yeah, that was something we're going to patch, or we have patched, and obviously your customers haven't installed the patch, unfortunately.
Do you have the ratio number for severe security bugs found by us versus by external?
I don't know if we have that number. I don't.
I don't know if we have the number offhand, but the question was, do we know the ratio of publicly versus internal fixes that we have done for security patches, correct? I can tell you it's probably 95%, just off the top of my head. There's no data here, but I mean, just from my experience over the last 2-3 years, for IE, the stuff we've patched has probably been about 90% from external finds. Yep.
Do you guys consider turning off the WebDAV redirector as part of the file system? Because obviously if someone's using the file protocol to an external site kind of thing, you're going to consider that as being within the intranet zone.
Well, yeah, I wish they would turn it off. The question was whether Microsoft is considering nuking the WebDAV protocol. The WebDAV protocol, for people who don't know, is it's an extension to HTTP which allows a web server to. Sorry, I stand up instead of sitting over in the corner. It's a protocol that allows. Basically, normally if you share files between Windows boxes, you use UNC file paths. SMB is the protocol. But that doesn't work over the internet, and it's not very secure either. So typically what WebDAV does is allows you to connect to a web server and share out files in the same method over port 80. So it'll go through proxies, it'll go through firewalls, and it's ugly because typically sometimes some of these encoding exploits, one of which I showed you, was over a UNC path. Well, you can actually do it over WebDAV, and so anybody can get hacked with it. Now, to answer your question, is Microsoft actually considering disabling WebDAV? Not that I'm aware of. Actually, Internet Explorer doesn't own that component. It's a different DLL. I wish they would. I'm not aware of what they're doing. There's actually no way to turn it off, which really annoys me.
Well, it would be good at least to have an option to say, I don't want the WebDAV redirector, on the system.
Yeah, it's a good point. It's something we've talked about. Mark?
No, I was just going to say, we should bring that back to us.
The trick with, the WebDAV, the protocol, Hotmail uses it. Now, the WebDAV redirector itself, I don't know how much it's involved, although Hotmail will work over IE.
As far as I'm aware, if I click on a file protocol, like file:// like foobar.com, it will try and connect over portal by 139 and then eventually trip over to call 80. In Internet Explorer. So I know it's not your fault because it's not your area.
Yeah, but it's Microsoft's problem, and we're Microsoft. I agree with you. I mean, it's something we always try in our variations, and something we've always complained about. I don't actually have the big picture on what's going to be done with it. I know it's a good point, and it's something we're going to push. It's good feedback. I agree with you. I mean, it's something we've said in the security.
That would be see Aaron on boots on here, click on this link, send someone an email, file colon, and that's going to force the privileged zone to be the intranet zone. And obviously that's going to be a much more of a easy way of getting evil script to run.
Yeah, I agree. Typically, when we do the WebDAV redirect, we need basically another vulnerability. But the point is that anything you can do over UNC path, you can then do over HTTP. And then, yeah, I agree with you. And it's a good feedback, and I know we're going to push it more. To be honest, it helps also when the external guys bring these issues up, because sometimes they listen more to external reporters than internal. Just because, it takes, whether you like it or not, sometimes it takes a public exploit or an ugly issue to come up and say, hey, people, really, we can't tolerate this anymore. We're just going to have to take the more severe course and block something off, as opposed to continually getting hacked with these issues.
We can hold off some additional questions till after, but what we wanted to do, I know some people will be leaving for other meetings, but for the people who are still here, I wanted to actually call up David Litchfield from NGS Software, and he's going to be talking a little more on buffer overruns.